don't want to see that. Yeah. So this is the talk, rewinding the time with system version tables. So quickly about me, my name is on the slide. I work in Medical Corporation as VP Server Engineer, and I was core MySQL developer since 1998 till 2009, and since 2010 I'm working on MariaDB. So what this talk is about? It's about a feature called system version tables, and before introducing it, let me describe three rather different problems. So one is the task of undoing erroneous statements. You know, we made a typo and the where clause, you occasionally deleted the whole table or updated everything to one, stuff like that. Then you want your data back. The other totally different problem is analytics on historical data. You want to see a web shop or online game, you want to compare your user base from the last year to the user base from this year to the user base from 2 years ago, see how demographic has changed, whether the user spent more time, and derive probably some useful hints how to improve your business. And the third problem is forensic data analysis. It's when you suddenly realize that your site was hacked and it was half a year ago and you didn't notice that, and you urgently need to know what the data intruder has seen, what user data has leaked, and what users need to be informed and what to do about that. So what all these problems have in common is you need to access your data as it were some time ago, some kind of a small time machine to look back and see at your data how they were. This is exactly what system versioning is. So system dash versioning tables, it's a standard name for the feature. It was introduced in SQL standard 2011, implemented in MariaDB 10.3. System version tables is a new kind of table, so there are like normal tables, there are temporary tables, and there are system version tables, which are not temporary, they are persistent, more like normal tables. And there's new syntax for creating those system version tables, and the new syntax for querying this temporal data. So first let's see what the standard has to offer. This is not a system version table, that's a perfectly normal table that has some primary key and some data. And let's say we want to make a system version. So that's the standard says we need to add two columns, they're generated columns. One is generated as row start and second is generated as row end, and they have both the timestamp type. I use the maximum possible precision, timestamp 6 microseconds, and the names could be arbitrary. Then this standard introduces a new object inside the table. So there are primary keys, there are check constraints, foreign keys, columns, and since 2011, there are periods, which is also something inside the table, and it has two columns. And so for system version tables, you need to define period for system time with those two columns. And then you need to write with system versioning, and after that you have system version tables. Congratulations. But why would you want to do that? What can you do with such a table? So the new thing is, instead of just using table name in the select query, you can specify table name for system time as of some arbitrary timestamp. And this is where the magic happens, because if you do that, you'll see the content of the table as it was at this specific timestamp and not as it is now. So this is your small personal time machine to rewind the time and see the table as it was at some arbitrary point in time in the past. There are also two other versions of the syntax for system time. You can specify for system time between two timestamps. Then you will see all the rows that existed at any point in time between those two timestamps. It's getting a little bit weird, because if the row was added, say, I don't know, on January 1st and deleted at January 2nd, and then another row was added at January 3rd and deleted at January 4th, this between will show both rows, although there was no point in time where those two rows existed at the same time, but this statement will show them both. It has some usages, but it will show inconsistent view of the table. It might do that. And this is again the standard syntax, but it's a very slight variation of this one, because between means that both ends are inclusive, and this one includes the first end and excludes the other one. So actually those two queries will return exactly the same thing, but this one includes ends of, this means everything up to end of January, including that one. This means up to, well, 1st of February, not including the 1st of February, so it's the same thing. I don't know why they did this. two same things in the center. And how you can actually use this practically. This is an example of this analytics on historical data that I used as a problem earlier. So this is kind of online game, and this is the table with users. And now we join in the table of users as it was in the 2019 January 1st, and with again same table as it was in 2020. And the users who spent, I don't know, more than 100 hours or some units of time online, and probably we could derive some useful analytics of that. So this one is joining two historical views of the table with itself and comparing them. And example of the from to, presumably this is a table of some kind of bank accounts. This query will show all accounts that had a negative balance at any point in time in, well, last year. Even if the account balance is not zero, is not negative now, this query will show all the accounts that had balance zero, negative balance at any point in time between, well, January 1st, 2019 to January 1st, 2020. This is again an example of analytics on historical data. So we've seen this is what standard allows us to do, but we added some extensions in MariaDB to make it more user-friendly, more easier to use, and faster to use, more convenient to use, these kind of things. So first we simplified the syntax, because if you do that perfectly, exactly as in the standard, you need to do a lot of typing, and if you do select star, you will see those timestamps that you don't necessarily want to see, just want to have your table system versioned without all this extra stuff. In MariaDB you can just write with system version without anything else, and then you get system version tables. The history will be tracked, you can still query it as before, but you don't need extra columns, you don't need those period thing, anything. Another thing MariaDB supports non-versioned columns inside system version tables. Again, this is not a standard feature, but this is a table of users, and every user has user ID, name and address, and presumably every time the user logins, we increment the counter of how many times the user has logged in. Those data are very static. This changes like very often, and it would populate the history with unnecessary information. We don't really intercept how many times the user has logged in. We only want to track how often, when his address or name is changing. And this one is not really part of the history that we're interested in. It will just blow up the history unnecessary. So in MariaDB you can specify that this column goes without system versioning, and then it will not be versioned. It will not create a historical version every time a user logs in. It allows to save a lot of storage space this way. Now, maybe some of you is thinking, and the first time MySQL developers heard of this feature. There's MariaDB 10.3, so it's not a new feature. I definitely got this question. So in the DB, as a transactional engine, timestamp when the row was inserted or deleted, it doesn't really define the time when the row becomes visible to other transactions, because the row might be inserted at one point in time, and transaction may be committed like a few hours later, and until it's committed, nobody can see the changes. So using timestamps this way, it will allow to see the data that before they were committed back in history. And in some points, for some applications, it's fine. Like if you do this over the year analytics, then a few seconds for a transaction, it'll give you slightly incorrect data, but it doesn't really matter for the time spent over the year. But if you want to do auditing or stuff like that, then it might be very important. And we are allowed to specify those generate columns as begin and signed, and then in a DB we'll store transaction IDs there instead of timestamps. And then it'll be precisely transaction precise versioning. It'll show only the data that were actually committed and visible to other transactions at any given point in time. And now that's another problem. The table written that way, it'll store, it's system version tables, it'll store all the data and historical data in the same table, which means, well, any change on the table will grow, it will never shrink. It means if you do, the indexes will grow and they will grow, so the queries will get slower and slower. And if you are unlucky enough to do a full table scan for some bad query, it will be much, much slower. And also, it'll it'll take a lot more storage, but the fact is that historical data, they are very rarely needed. So most of the time you just want to use the current data, and eventually, rarely, you want to look at what happened some time ago. So it makes sense to store the history separately so that it won't slow down the day-to-day operations. And our solution is to partition table by system time. Then you create a partition for current data and partition for historical data. Historical data will be stored separately, and optimizers are smart enough to realize that if you don't use any as-of things, then you only need current data, then it'll do partition pruning. This will never be opened or looked to. It'll be basically as fast as not having any system version at all. You can even rotate partitioning by having many history partition and say, like, I don't know, 1 week of history for every partition. For this one, you of course would need more than one partition, more than one history partition. And then you'll have 1 week of partition in here, 1 week of history here, 1 week of history here, and so on. New partitions will be not added automatically, at least not in MariaDB 10.3. It's a new feature we are working on now. So, but every month or every few months you can add new partitions here and drop few history partitions, keeping history, well, reasonable. And this could be, of course, any interval you want. And a couple of new ways of querying the data one can specify in MariaDB for system time all, and I think Microsoft SQL Server also has the syntax, which will be like having a very wide range. It'll show all the history and all the current data. And because InnoDB can store transaction IDs and not timestamps, there's an optional way of querying exactly transaction by transaction ID. It'll show the data that this transaction has seen. How much time do I have?
You still have 8 minutes.
Okay. So now I can talk about the new configuration variables that are useful in configuring this system versioning thing. First, because most of the time system versioning, it relies on current timestamp to know when something has happened, when the row was changed. And traditionally in MySQL and in MariaDB, current timestamp within a session, any user can modify it arbitrarily. So a user can totally subvert the history and create non-existent histories and change timestamp to 5 years ago and then to 10 years in the future, and it wouldn't make any sense if you look at the history later on. So in MariaDB now there's a way to restrict users who can modify the current timestamp within a session. The default value is for secure timestamp is no means timestamp is not secure and behavior is backward compatible. Anybody can modify the timestamp within a session. But it can also be limited to a super user, so only super user can modify the timestamp within a session. Alternatively, there's an even more stricter configuration where secure timestamp is restricted to replication, meaning even the super user cannot mess the timestamp, but the slave will still follow the timestamp of the master, and when the slave is replicating, the timestamp on the slave will be exactly the same as it was on the master. And the extreme configuration setting secure timestamp to yes means nothing ever can change the timestamp on the slave or on the server. It will always be the system timestamp watching the clock of the operating system. And then you can be sure that the history goes exactly as system clocks say. But the drawbacks are that the history on master and slave will be slightly different if the clock is not synchronized.
Come on, we're in the middle of the talk, please. This is rude, please.
Yeah, actually, that's why I'm always thinking that Postgres has a benefit over MariaDB on MySQL, because I have real difficulties imagining a dolphin walking in, or a seal. Anyway, so, and another related configuration variable is system version alter history with the default value of error. According to the standard, you cannot do alter table for system version tables. It should be an error. So if you do alter table add column, it'll fail. We thought that's the default behavior of MariaDB as well, but we thought it might be more user-friendly and many users might still want to support alter table. So we have a new other behavior with the system version alter table equals skip, which means you can add a column and then it'll work. The history will be preserved. But if you'll try to look at the history of the table before you have added the column, you will still see the new column. That is, the metadata are not versioned. You still see the new metadata. But for existing columns, you'll see the old values exactly as they're supposed to be. And how much would this feature cost in terms of performance? This is a very simple benchmarks. Percents are comparing the performance on system version tables as compared to the performance on non-system version tables. And with partitioned and non-partitioned. This is, as you might guess, this is sysbench. So as you can see, the inserts are basically go at full speed. There's no slowdown for inserts at all. If you look at deletes, deletes are 20-30% slower. And again, those numbers are they're just ballpark. They probably would highly depend on your application. This probably won't. This definitely will. But I just want to show that it's not like 10 times, not 2 times, and it's not 0%. It's sometimes it's 5, 10, 20%. It's something you might expect, realistically expect in your application. How it gets slower if you turn on system versioning. So delete is always slower because you don't actually delete anything. It's deleting the old row and inserting the history row. And that's extra work every time you delete something. So delete will be always inevitably a little bit slower. Read-only load is also slower simply because the primary key got longer in the system version tables. And there's an asterisk, meaning there's an MDEF feature, a plan to fix that in partition tables, but it's not possible to fix in non-partition system version tables. Although, again, this is very much depend on your application, depending on primary key length. If you have a very short primary key, then extending it will, system version might extend, it will happen at timestamps, so it might extend like a few times. If you have a reasonably long primary key like UID, then the slowdown will be much less. If you don't have a primary key at all and rely on InnoDB generated primary key, there should be no slowdown whatsoever. And OLTP read write, this one is a little bit confusing. So what I've done, I've run the OLTP read write benchmark 3 times on the same data without regenerating the data. And the first time I got a 60% speed, like 40% slowdown. 6th time I got 50%. 3rd time I got 40%. If I would run it more and more, it would be slower and slower because every time I run OLTP read write benchmark, the rows are deleted and updated, so history is accumulated, table grows longer, and that's why the benchmark system version table is getting slower compared to non-system version tables. And this is exactly the use case that partition table is supposed to fix because it keeps the history separately. The table is not getting slow because the current data is not growing. All the changes, the historical data are growing, but historical data are not getting queried in sysbench benchmarks. So this is exactly the use case when partition table is fixing. It removes the slowdown that one would observe in non-partition system version table. This is it. Thank you. Any questions?
Yes, does it work on Postgres?
I'm not sure. You had to ask the blue elephant. Yes.
Will it be possible to enable the versioning table only on a slave?
Yes. Those one of the use cases we are thinking about.
But then the times will only be on the slave.
Not necessarily. So normally the master, it includes the timestamp in every event. So there's a problem when the master includes the timestamp without microseconds and slave needs it up to the microseconds. Then the slave could guess some arbitrary number of microseconds, just a little bit, use increasing number. Otherwise, it'll use a timestamp from the master, so it'll mostly follow the master. Yes?
You have shown an example where we can see the content in a period of time. Is it possible to see the content, for example, one row, all the changes?
Yeah, yes, but then you just don't use. Oh, there are actually 2 ways to do that. Yeah, so you can do all and just where ID equals something.
Ah, okay, I missed that one.
Yeah, because this one is part of the table name, so this is basically the table. Then you could anywhere clause and everything. Yes, please.
What happens if you try to join something with that data?
So this is the join, and so I just said this thing is basically part of the table. So this is the table users for, this is another table users for blah 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 blah, and then this is a join using ID, and this is just the join. So you can use this thing anywhere where the table name is expected. Yes, please.
So with the amount of changes, the volume is going to be very large. Is it possible to squash once in a while? Like if the same row has been updated 5 times, just merge it?
No, no, you cannot. You can periodically remove old partitions and keep, like, I don't know, 3 months of changes and delete and drop other partitions. But generally delete doesn't work because, well, it contradicts the idea of immutable history. Yes.
So in the partition case, don't you have to move a row from current to history partition?
Yes. Yes. That's why I said that delete is basically delete plus insert. You delete from here, you insert here.
It would also update.
Yes, and update is just insert because you update here and you insert historical row here. Updates are also slower, inevitably.
Okay. But if you have a row in current and then you update that row, don't you have to move the former version from current to history?
No, it's update of this row in here and insert of the old version in here. It's update plus insert.
Yes, but I don't understand how you can get almost the same.
Because LTP that benchmark, they're mostly doing inserts. Inserts are generally much faster than updates, so you didn't lose anything on inserts, reads. It's doing mostly reads, and you won so much on fast reads that everything else is very hidden. If you ask about exact data, on 3 runs I had 35% on one, 38 on the other, and like 102% on the third one. So it's a fluke. It's few percent and don't really matter much. Yes, please.
So 2 questions. The first one, is that a feature of the server or of the storage engine? Is this an InnoDB or is this in the server?
This one is in the DB because it need to know in a DB transaction IDs. If you use timestamps, it's completely in the server.
And so the second question is, could we leverage the undo log of InnoDB to reduce the costs of maintaining the version? So basically, in the purge of InnoDB, populating the history as we purge.
This is how Oracle implements it, as far as I know. They use the undo log and versioning. It probably can be done inside an DB. It'll be a lot of work to do it, to leverage the undo log, but pretend that from the server point of view, it's still a table.
Also, so what I mean is the history.
Yeah.
We just do the transaction in the table.
Yeah.
And then instead of populating the history real time, as we purge.
Yeah. I understand. So.
The idea is that searching should be as fast, even if you have history or not. With this one, we get same speed for search. If you have the undo log and you have millions of things there, you have to go a long way.
Well, every time when you purge the undo log, you populate the table. So then well, I think that's what Oracle is doing with flashback minus populating the table. Just keep the data in the undo log, and then it's purged, forever.
There would be a little lag of the history
Yeah.
in some way,
Yeah.
but maybe the cost would be.
Yeah. So it would totally make sense, and unless you want to see like exactly very fresh data.
Okay, thank you. No more time.